In this video article, we describe a novel high-throughput protocol for the automated solution phase synthesis of oligosaccharides and the functionalization of polyanhydride nanoparticles with these carbohydrate-based targeting agents. First, carbohydrate molecules are synthesized using an automated system that utilizes solution phase synthesis instead of solid phase synthesizers. Next, the oligosaccharide intermediates are purified by Fluorus solid phase extraction, or FSPE. The produced carbohydrate molecules are characterized by NMR, and then they are attached to the polyanhydride nanoparticles by carbodiamide conjugation. Finally, carbohydrate functionalized nanoparticles are characterized by X-ray photoelectron spectroscopy and a high-throughput phenyl sulfuric acid assay. Ultimately, utilizing the high-throughput methodology described here, the reaction conditions to optimize nanoparticle morphology and carbohydrate density on the particle surface have been obtained.
The main advantage of this method over the existing ones, like solid-phase oligosaccharide synthesis, is that in this method we use substantially lower amount of building blocks. In this method, typically we use 2 to 3 equivalents instead of 10 to 20 equivalents.
We first had the idea for this method when we demonstrate the efficacy of surface functionalization of polyanhydride nanoparticles using carbohydrates to target C-type receptors on antigen-presenting cells. We then wanted to design a high-throughput system that will enable us to screen the multiple parameters that are involved in the fabrication and application of these novel carriers.
Visual demonstration of this method is critical because the development of automated platforms for the high-throughput synthesis of oligosaccharides and their attachment to polymer particles is a novel area of investigation without a lot of documentation available.